So welcome to the day 5 of our virtual trainings in RHCE. This is Alok Srivastava. So what we are going to learn in this day is very important and it's actually very interesting. We will be learning about the process. So what we are going to learn, let me just explain it to you. I might be requiring an editor here because I need to write a lot of things for you. So we will be learning the objectives for the day 5. Day 5 we are going to learn about what is a process, what are the different types of processes available, this is very interesting. And as far as the commands is concerned, we will be learning about how to list the process, listing of processes. We will learn how to kill a process or end a process, and we will also learn how to monitor it and then change the priority of the process, monitoring processes. And finally we'll be learning about changing priority of processes. So these are the objectives of our day 5, and I hope that you are enjoying this one day one video concept, because I know that your schedule is very tight and you are really fighting it to get yourselves RHCE certification, which is no doubt worth going for it. So let's understand what is a process. So process carries out any task in the operating system. So a process is a computer application which is doing something. Like presume say I had opened a Firefox. So it's a process. So Firefox is a process because it is doing something. It is in action. Anything which is doing something in your machine and is action is a process. So process is, you can say, it's a program in execution. So as you know that Linux is a multi-processor operating system. That's great. So we can run multiple processes simultaneously, which we are doing it actually. And remember one thing, each process does separate tasks with its own right. One process cannot interfere in the domain or the realm of the other process. And in case one process crashes, it will not cause the other process to crash. So in case my Firefox is shut down or it's crashed, it won't let the other applications like gedit or vi editor or anything which I'm doing will crash. So and each process runs in its own virtual address space and they cannot interact with other process except it should be managed securely by the kernel. And remember, as I have told you, that process is anything which is running, which is active in your machine. It's carrying out some task is a process. So a process will always use number one, it's very simple. It will use my CPU, it's going to use my memory obviously, and it's going to use my hard disk, because a process can open multiple other files directly or indirectly. It can happen, and it is the responsibility of the operating system that it must keep track of all the processes, how many processes are running in my machine. It has to be taken care by the operating system, how much memory is allocated to a process, and the resources. All these three resources should be divided into all the process in a fair manner, so that no one process can dominate all the resources. So if you want to try to understand a process does what? A process is normally, I can give you a very simple example of a human being. Consider process as a human. like human, what happens to us? So process is like human. Okay, it's a very interesting example. How a process is like a human. So if we consider our life cycle, how the human life cycle goes. So we have parents. So parents give us birth, give birth to the children. So I'm a child process, right? So and after the birth, once after the birth, what we do? We start living in our home, our neighborhood, with my own friends. My friends will be different from your friends. My area or location will be different from your location. So after birth, humans start living in their own surroundings, right? So humans start living in their own surroundings. Right? And I will be using my available resources, using whatever available resources are there in the surrounding, using available resources for my survival. So I can call it that if this is my state, like currently the process is in running state, isn't it? Process is in, sorry, running state. Because I'm living in my own surroundings, I'm using the resources to survive. So the process is in running state. Now, at some point of time, I might need to wait. As a human, I might need to wait for something to happen before I can continue to the next step. Let's see, I'll give you a very simple example. I have to wait for a girl to get married. So I cannot go to the next level of parenthood before I should get married to a girl. So at some point of time, humans need to wait for something that they must have before they continue to the next step in their life, like waiting for the girl to get married. So we call it the process is in a waiting state, right? So this is a waiting state. So when humans, like I can write here, humans have to wait for something that they must have before I can continue to the next step. Right? In my life. Like I have to wait for a girl to get married. Like I can write here. So marriage state cannot be reached before I get a girl. And finally, like humans, death is inevitable. So like every human, the life must come to an end for every process. So at the end, a process may die, will die. And like I can write something like this, like humans, human life must come to end. In the same manner, every process must die. It's very simple to understand. Just consider it this example. So it will be always very easy. So you to understand. We will have some parents giving birth to us. So I am a new process. After birth, I will start consuming some resources from the nature or from my surroundings to survive myself. So I call it that I am in a running state. When I am waiting for something to happen before I can go to the next state, we call it a waiting state, right? And finally, a process must die, like human life ends. So there are multiple types of process. So as I've given a very simple example for you, like this gedit which I'm running here is a process. If I open a Firefox, it is a process. Any application which I open here, I open one more terminal. It's a process because it's consuming CPU, memory and hard disk. So we have different types of processes available in Linux. Process types. What are the different process types available? So we have three process types major. One is the user process. User process. What is the user process? The user process is normally started by a regular user. So I can write here, started by a regular user. And they run in user space. And they run in user space. Right. And a user process will have no special access to CPU or memory or hard disk or to the files that doesn't belongs to the user who has launched it. So it's a normal like process. So it has no special access to CPU or to the files that doesn't belongs to him. He cannot access any other user's file. Right. So it's a user process. Like a user process might be if I had launched the Firefox. So it's a user process as it's being launched by the user Alok. I'm logged in as user Alok. So it's a user process and it doesn't have any special privileges. CPU is not going to give any undue attention or say extra attention to it. Second is the daemon process. Demons, yes, like the demons, they run in the background. So they are designed to run in the background. So normally they run as a service. They are designed to run in the background. They normally managing some kind of ongoing service. I can write here, managing some kind of ongoing service. I'll give you one simple example. So it's a daemon is a process which is running in the background. It's not coming here right on your terminal, but it's scattering you some service. So if I go here and just give a command here, sshd. So sshd, and one very interesting thing is that all the daemons, they end with the letter D. D stand for daemons. C, open SSH server daemon. So it is running in the background. It's not, I cannot see it like a ghost or a demon actually, but they are running in the background. They are doing the job, like Apache or like SSH, like cron. So I can write here, it's like your SSHD like service or HTTPD. If you have got a web server running, they are daemons. They run in the background. And the cron is a very good example. What does cron do? So cron D is a daemon which is supposed to start some activities automatically, like actual daemons. They automatically start some things. So cron D, we actually hadn't learned about cron D yet, but cron D is the daemon which automatically starts some jobs for you, like a ghost or a demon. So these are the processes, right? And remember one thing, daemon processes are normally managed as service by the user root. Normally managed as service by the user root. So I had just shown it to you also. Then when I had shown you SSHD daemon, so it's a daemon, it's loaded active. So it's managed as a service. Normally they are managed as a service. So I can stop this service. So I have the control. Some daemons gives you the liberty to control their state. So I stopped it. So if I give status here, it's stopped. It's not active, inactive, dead. So I can start it again. But there are some daemons which don't allow you the flexibility to control them. I'll tell you what kind of daemons are they. So daemon process are normally managed as a service by the user root. But daemon processes, they don't run as root. It's very important point from the security perspective. So daemons process often run as non-root user. This is very important. So what normally happens, a user account is created which is attached to that service. I'll show it to you. So that's a non-root user by a user account that is dedicated for the service. Like, I'll give you one simple example, like HTTPD. If I show you here cat etc password, so you see there is a Apache user account is there, SSHD user account is there. So SSHD service, the daemon is not running as root. It is running by using that non-root user account SSHD, like FTP. So normally whenever you try to run any daemon like postfix, SSHD, NTP, cronny, so these are the user accounts, non-root user accounts which are dedicated for that service. So if Apache will be running, it will be running by the credentials of Apache user, not the root. So this is actually a very good thing for the from the security perspective. Like HTTPD will have a user account, like SSHD will have a user account. So they are non-root user. So advantage of running the daemon process as the non-root is that the system is much more protected. So in case of an attack, in case my Apache is compromised, say my Apache got compromised, but Apache is running as the Apache user, not the root user. So it would give attacker no special access to other files and folders which are not owned by the user Apache. So even if the Apache got compromised, the damage cannot be extended to HTTPD and all other things because it's running as a non-root. So I have told you that advantage of running daemon process as non-root is that system is better protected, better in the event of attack. So these and daemons are normally, they are started at the boot time and they run until the system is shut down. So like SSHD gets automatically started. I didn't started this. So it will start when the machine start and it will automatically end when the machine ends normally. So daemons are so often started at boot time and run until the system is shut down. But as I have told you that there are certain daemons which run as a service. So daemons can be started or stopped by the systemctl command as I had just shown you. So daemons can be started or stopped using stopped on demand using systemctl. Like this. I have, though it's a daemon, it's running, I have the power of stopping it. It stopped. Then I have the power to start it. It started. These are the daemon process. Then the third process is the kernel process. Kernel process. So what the kernel? They are exactly like daemons, more or less. They are similar to daemons. But there's a difference here. They're similar to daemon, but they execute only in the kernel space. They run or execute in the kernel space. And the difference between the daemon and the kernel process is that kernel process have full access to kernel data structure. That makes them more powerful than the daemon process that run in the user space. So you can write here, primary difference is that kernel process have full access to kernel data structure. That makes them more powerful than daemons. Process. And they are not flexible. They are not flexible as daemon process. I cannot change the behavior of the daemon process. Oh, sorry. I can change the behavior of the daemon process by changing the configuration file. But for changing the behavior of the kernel process, I may need to recompile the kernel. So it's very interesting here. Not flexible as daemon processes. Why? Because I can change the behavior of daemon process by changing the config file, by changing the configuration files. It's very easy. But to change the behavior of kernel process, I may need to completely recompile the kernel. So that makes it more difficult. Like I'll give you one simple example. By default, SSHD runs on port number 22. So how can I change the behavior of this daemon process? Very simple. If I go to etc sshd underscore config, and from the port 22 here, from the port 22 here, if I change it to port number 222, so I restart the service, systemctl restart SSHD. So I had just changed the behavior of the daemon process. It's not running because of SSH like SE Linux, right? But I can change the behavior of the daemon processes. So if but changing the behavior of the kernel process, it's very difficult, or it's not that easy to change them. Now, before we come on to like on the commands, we now need to understand different process states. So normally the process states, they are normally, you've got two process states. Either the process will be running, that means it is active in the CPU, or it's not running, that is the process is off the CPU. So I can write here process states. The next point is process states. So idea is very simple. Most processes are in one of the two states. Most processes will be in one of the two states. The Two States is a movie also in India. So one is running state. So running state simply means the process is in the CPU, is on CPU. It's active. CPU is working on it. And the second is not running state. That means process try to make things simple is off the CPU. There are two states. So I will be showing you certain commands via which you can see whether the process is in running state or waiting state, or it's hanged up, it's defunct. So only one process can run at a time on a single CPU. All other processes have to wait or be in some other state. Right? A process which is not running, it might be in a runnable state, a sleeping state, uninterrupted sleep state, defunct or zombie state. There are multiple states if the process is not running. So let's see now, we'll come on to the commands, how to see or list the process. So it's very simple. I have got a PS command which shows me the process. So if you do a man of PS, you see here, it reports a snapshot of the current processes. So PS displays information about the selection of the active process. So there are multiple options which we will be using here. Like it will show you me the processes. Sorry. It will show me the processes which are running on the current state or the terminal. So if I give the command PSAX terminal independent, show me all the processes, either they are daemon process or kernel process, and wherever they are running. So if you see here, it throws me a lot of information. I'll just show it to you. We have to scroll up. Here it is. So this is every process has got a PID, like a user has got a UID. What is the state? It's sleeping. What time? And the command. And I can give one, make it more illustrated by just giving a L here. See here, it gives me a much more information than the PS. These are all the processes which are running. So every process has got a UID, a PID, a parent PID, which is the parent process. See here, as system D is the first process, so the PID is 0, and because it is the first process from where everything has started, obviously it won't be having any parent. The priority, the nice value. What is nice value? I'll be showing it or explaining it to you. VSZ will show you the virtual memory in kilobytes. RSS will show you the non-swapped physical memory in kilobytes. What is the state and on which terminal? So if you see there, the terminal is question mark. So the terminal is not available. So chances are that they are running in the background, that they are the daemon processes. See here, like this is attached to the terminal TTY1. And by seeing the parent, you will be able to find out that which process has started which process. See here, process 3 has got a parent PID of 2. That means 2 has forked it, 2 has started it, right? In the same manner, so all these processes are started by this process 2. It is the parent for all these processes. I can get a very like another command is a very good option is the EF option. It shows you the user information also, which user has started the process. So see here, user, PID, terminal, time, and the actual command. So normally they are started by root. As I've told you, they might be the daemons, and certain processes are started by alloc. So I'll show you. If I open the Firefox here and will give the same command again, you will find the Firefox coming up somewhere. Here it is, and it started by user alloc. This is the PID of the user, of the process. Another interesting command, so please go through the man pages of the PS. It gives you a very good examples here. I can have a process tree also, something like this, ps-ejh. So it shows you the parents and everything. So you might think that, oh my god, I am dumped with a lot of information. One important or very interesting command, if you want to see the process hierarchy, how the process are started, is the ps tree command. So ps tree will show you the processes in a tree format, how the things have started. So everything is started by system D, then system D has started these processes, and these processes then again fogged these processes. It gives you a complete tree format, like we have the tree command to see the directory skeleton. So ps tree will show you the process skeleton. And in case you are interested in seeing the processes which are started by a specific user, you can write here, sorry, alok. So all these processes are started by user alok. So if you are interested in seeing that what processes are started by alok, not by the root or not by the machine, so just replace it with a username. Add the username. So it will show you all the running processes. One live command which you can use to have the process is the top command. The top command will show you the processes which are taking most of the system resources. If you see here, it will keep on refreshing itself. So the processes which are taking most of my resources will be coming up at the top. The top in itself is coming at the top. So this is the PID, the user who has initiated it, the priority, the nice value, the virtual memory as the CPU it's consuming, the physical memory it's consuming, the state it's running, see. And my Firefox is sleeping. So if I just try to hit a google.com here, which won't work, but you will find it comes at the top because it's consuming the resources now. And you can use the top command for a lot of things. You can kill a process. You can do a lot of things using the top command. So any point of time you can press H to get all the help available here. And you can see K for killing the process, R for renice the process. I will explain you what is renice and how to kill, Q to quit, any point of time. Now let's see how to kill a process. Why I should be killing a process? Might be the process is hanged, might be the process is defunct, it's not shutting down properly or manually. Let's presume I'm not able to shut it down from here. So how? But I need to kill it. So first option is I can give the command PID of Firefox, because every process is identified by a number. So I get the number 7160. I just simply give kill 7160. See here, it's gone. Firefox gone. You have just killed the process. So when you kill the process, it sends certain signals. So if you want to list all the signals, write kill-L. So these are all the signals which are used for killing the processes. 1 is your hung up signal. 15 is the default which terminates it gracefully. 9 is kill, abrupt killing, right? It may lead to your data damage or corruption. So you can use the signal. So by default it uses the 15 or the like the graceful killing. Kill can be used. You can also use your system monitor for this. You see there, system monitor. So even you can use this. These are the processes. So any point of time, if I open the Firefox here, you will see the Firefox entry will appear up somewhere here. Here it is, the process ID. You can use this graphical tool also to end the process, to kill the process, stop it, change the priority and everything. But normally we will be going on to the CLI part to do the things. You can kill the process. So there are certain commands like pgrep. Also you can use the pgrep to find the PID. I'll show it to you. Sorry. Or you can use PID of Firefox. Uh-oh, I don't know why I press. Then you can kill the signal and send the kill. I can also give kill all. I'm not going to execute it. User allow. So you guessed it right. What it will do, it will kill the processes which are owned by the user allow. See, kill all, kill process by name. I can give my criteria also, right? So these things can be used. There is a very interesting command there. P-kill can be used. P-kill. So I just if I give this command syslog d, so I'm giving the signal. I'm changing the signal. I'm giving the signal hang up. So what it does actually, I'm forcing the syslog d to reread its configuration file using the HUP signal. So if I show you man p-kill, see there. So as I'm keep on repeating it from the day one, so I can give it for SSHD also that please make it a habit of reading the man files. Now that is fine. So I'm able to see the process. I'm able to kill the process. Now I should be able to change the priority of a process. Why should I be changing the priority of a process? Let's say my Firefox is running. So why should I be changing the priority of a process? Changing priority of a process. But why? The question is why I should do it. Let it run. Why I should change the priority of a process. Any guess? So normally you have got two conditions in which you might want to change the priority of the process. Number one, though it's not say directly related to Linux here, I'm just giving you a very simple example. Presume I'm opening some heavy multimedia application. I know that this application is going to consume a lot of resources. That might lead to resource crunch for other processes running. So I want that the process should be given a lower priority so that there should not be a resource crunch. So a process might consume all the resources, right? It's heavy. So it may lead to resource crunch for other processes. Very simple. So in that case, I might need to increase the nice value. Yes, you've heard it right. I need to increase. It's actually reverse. I'll explain you. I might want to increase the nice value. Second case is there is a very important task. Let's presume you are doing a backup and you want the backup to be completed fast. So you want that particular process to be treated special. Special attention should be given to that process. So I want to increase the resources to that process so that it can be finished fast. So in that case also I want to increase the resources to a process so that it can be finished fast. So in that case I will decrease the nice value. So what is a nice value? So nice value is what? So nice, as the name says, nice. Nice to whom? Nice to the CPU. So whether a process is nice to the CPU, so we call them the positive values, and whether a process is demanding more resources, that means not nice to the CPU actually. So there's a negative values. So nice values are ranges from -20, which is the highest, to 19, which is the lowest. So positive numbers are decreasing the resources and negative numbers are increasing the resources to that process. And any point of time when I run this Firefox, I am interested in knowing when I run a process, what is the priority allotted to this? Very simple, just give nice command and press enter. So by default, it's a 0 priority, means neutral. Now, how can I increase the priority of a process and how can I decrease the priority of a process? One thing, you can use this graphical tool. I had shown it to you, I think. Right click, change priority. Normal, high, very high, low, very low. You can use the top command. If I give the PID of Firefox, it's 7317. I give top and I press here R, PID to renice 7317, 7317. It says okay, what is the value? Say I minus 10. So I'm increasing the value. So that means it is being given more attention. The Firefox will be given more attention. So nice value will be changed. So if I just try to enter here and will show it to you, see here minus 10, nice value. The negative values, as I have told you, are higher values, means more priority. You can use the top command or you can use the nice and the renice command because the application is already running. So I give the command PID of, then I give the renice. See, if I give a PS AUX 5 grep Firefox, you can see there the I can give here L, I can give here, and I'll try to show you what is the priority that is given to it. See, minus 10. So if I change it here, I can give renice, say the new nice value, say 10, lower priority. I don't want to give it some additional or extra attention to it, and the PID 7317. See here, old priority 10, new priority this. If I repeat the same command, you will see it's not 10. So you can use the renice command to change the priority of a process which is already running. But in case I am closing it down, you want to start a process with a higher priority or a lower priority, then we have got the nice command like nice, say -n, say -10, vim, anything, @c password. So this VI will actually running with a higher priority. So if I open up one more terminal and show it to you, and I give the command ps and lax grep vim, let me show it. I hope it will come up here, -10 vim. So nice will be used to change the priority of a process at the time of running, and renice will be used to change the priority of a already running process. So guys, this is at least you should be knowing about the processes, and you also have the like control your jobs by putting any process in the background. I'll just show it to you. Let's suppose you are you had given a very big command or a huge command. Say if I give this seq, it creates a huge file, say big file. So I won't be getting my cursor back till the job is finished. See, I have to wait. I don't want to wait. It might take 30 minutes. So I'll first remove this file, big file. See, the big file is created here. Remove it. So any job that you think is going to take more time, you can put that job in the background by just putting an ampersand symbol at the end. So the particular job will be going up in the background, and then you can give the jobs command to see how many jobs are running in the background. So that can be done. So this is all for your day 5. At least you should be knowing all these things about the processes. I'll just repeat what we have done. We have learned about what is a process. I tried to explain it using the human example. different types of process: user process, daemon process, kernel processes. Then we had learned about the process states. Then we had used a couple of commands like ps and ps tree and top and kill and pgrab, kill all, pkill, nice, renice. So this is all you have to learn at this level to understand the process and monitoring and managing the Linux process. So this is here for the day, and in next class I will be explaining you how to control your daemons and services, and we will be learning SSH also. Very interesting. So till then, enjoy one day one video. Do come up with your feedbacks. Thank you very much. God bless. Take care.